So we have to show that root 3 is a irrational number. To prove this, we have to follow the contradiction. Already I have shown that root 2 is a irrational number, and here we are going to use a technique that is called as a contradiction method. In this contradiction method, first we have to assume that root 3 is a rational number. So here let us assume that root 3 is a rational number. So it is a rational number, we can write in the form of p by q. So here we can write root 3 equal to p upon q. Here you know that p and q are integers and q not equal to 0. P comma q are co-primes. Co-primes means here HCF of P and Q is 1. Means only 1 is the common factor and no other factors are there. So we can say that P and Q are co-primes. Whenever the two numbers have only 1 is the common factor, so then we can say that two are co-primes. Suppose one example, 4 comma 5. So only 1 is the common, therefore we can say 4 5 are co-primes. Similarly 7 8 5 6, all these are co-primes. Means here only the 1 divides these two numbers, so that's why these are called as co-primes. So now transposing q this side here, so we can write p equal to root 3 q. To eliminate the root, we have to square on both sides. Squaring on both sides here, squaring on both sides, it becomes p square and root 3 whole square and q square. So now we can write p square is equal to 3q square. From that we can understand that the square of the number can be expressed as the product of 3 and q square. So here p square expressed as 3 times q square. Its meaning is 3 divides p square here. 3 divides p square. Here 3 divides p square. Whenever a square of the number is divided by 3, then its number also divided by 3. Some example I will tell you here. Suppose p square, you can take 81. 81 is, we can write 9 square. Okay, 9 square is divided by 3. Here you see 3 1s are 3 2s are 27s are. It means here it is divisible by 3. Same way, the here p, what is the p here? 9. 9 also divided by 3. 9 also divided by 3 times 3. So it means here whenever p square is divided by 3, p also divided by 3 here. So from this we can write p also divided by 3. Then we can write here p can be written 3 times some number m you can write. So therefore p is equal to 3m. P is equal to 3m means 3 into something here. So therefore substituting the p value in the p square, 3m whole square is equal to 3q square. Now here 3m whole square, 3m times 3m, it is 9m square equal to 3q square, divided by 3 on both sides, divided by 3 on both sides. So now it becomes 9m square by 3 equal to 3q square by 3. So 3 ones are 3, 3s are 3 ones, 3 ones. So here we can write 3m square is equal to q square. Now you can rearranging that terms here, q square is equal to 3m square. Now here you see q square also written product of 3 and some other number. Q square also written 3 into something here, 3m square. It means here q square is divided by 3. Q square is divided by 3. Q square is divided by 3. Q also divided by 3. Q also divided by 3. From that we can understand that 3 is the common factor that divides P and Q. But our assumption is that is the rational and P and Q are co-primes. Our assumption is P comma Q are co-primes. This contradicts the fact. Here finally we came into P and Q are that are divisible by 3, but our assumption is P and Q are co-primes. This contradicts the fact. This contradicts the fact. So we can conclude that root 3 is an irrational number.